Hello students, in this lecture we are going to start a topic that is atomic structure. Okay, so in this atomic structure, generally this atomic structure you learned in the previous classes, that is either in the 9th class or in the 10th class, not total atomic structure, the first two sections. So that is the subatomic particles as well as the atomic models Okay, so these already you learned in the previous classes, but even though just I am going to explain it some important points. Okay, not all the theory I am not going to explain. I am going to explain the important points of this first two sections. Okay, and later that we can clearly explain the remaining things from third section. Okay, so first we can move to our notes, that is atomic structure, right? So this is our notes. What is the atomic structure? In the atomic structure, the first word atom, you know that the atom, it is derived from the Greek word, already you know, and that is nothing but the atomio, which means the atomio means uncuttable or non-divisible. Uncuttable or non-divisible. Okay, so why they kept this name is that because at that time, that means earlier 18th century, it was at earlier 18th century, they thought like this: whatever the atom is the smallest tiny particle, and that is uncuttable or non-divisible. That is the reason why they kept a name of atomio. Okay, simply in English we call it as a atom. Okay, so that means the atom which is uncuttable or non-divisible. Okay, at that time, but not now. Okay, right. So the first modern atomic theory was proposed by John Dalton, called Dalton's atomic theory, and according to Dalton's atomic theory, the atom is the ultimate particle of matter and indivisible. Okay, you know that the matter, whatever the matter in the earth or in the universe is made up of small particles, made up of small tiny particles, you know that, right? Like take any iron or something, any plastic or whatever it is made up of a small teeny particle, right? And that particle, according to his theory, Dalton's atomic theory, that was in the year of 1808, they assumed that was the smallest particle and that was indivisible. Okay, and what is that? That is nothing but an atom, right? And now in this chapter, we are going to talk about that atom. We are going to talk about the atoms. Okay, so that is the reason the chapter name is atomic structure. Okay, but later, that very soon, when it was around 1808, but after that what happened? After the few years, the scientists realized that the atom could gain or lose charges during the electrolysis experiment. Okay, and what they did is that, you know that whenever the technology grows, the scientists discover new things. Okay, and after the whatever that thought of atom, the scientists very soon they discovered that the atom can gain the charge and simultaneously can also lose the charge. Okay, and with this, who identified that? That is Michael Faraday. Michael Faraday discovered that the atoms were acquiring some negative charge during the process of electrolysis. Okay, again they are also losing some charge during the electrolysis. Okay, then if the atom is, then they got some doubts on that. Why? If all atom is an ultimate indivisible particle, then how and what it is losing? If suppose this atom, this is nothing but an indivisible particle, okay, if it is indivisible and on electrolysis process, why it is losing charge? It's losing, or sometimes it is gaining some charge. So okay, so charge, what that means, something it is losing, the particle is losing something, or something it is gaining. Okay, so with that they came to know, not this atom is not indivisible, the atom was not indivisible, something is there inside to that. Okay, and with this the scientist again started finding something is there inside the atom. Okay, and finally what they concluded, with the experiments, what they evidenced is that with the experimental analysis they began to show that the atoms were divisible and are made up of some small particles. Okay, so since these particles are smaller than the atom, okay, obviously whatever the particles inside that atoms are should be smaller than that. Okay, so finally what they concluded is that the atom is not indivisible, the atom can be divisible into small particles. Okay, and what are the particles? Those particles they called it as a subatomic particles. Okay, so what are the subatomic particles? What they found is that those are nothing but the electron, protons as well as the neutrons. Okay, that means an atom, it consists of subatomic particles, and those subatomic particles are nothing but electrons, protons and neutrons, right? Okay, and up to now, even from the up to 21st century also, this is the these are the achievements. Okay, maybe in 22nd or 23rd century, maybe in future you people are may discover something, the electron again can be divisible, a proton can again be divisible, because that depends on the technology. Okay, whenever the technology develops, you can find out the smallest things, you can discover the smallest things. Okay, but right now, up to now, the atom can be divisible into subatomic particles, those are electron, proton as well as the neutrons. Okay, and next we can go to the subatomic particles. This I am not going to explain thoroughly, just I'll go with the important points, that the subatomic particles, you know that is the electron, protons and neutrons. Okay, and who discovered the electron? The electron discovered by the, who is this? J.J. Thomson, but that was this Michael Faraday done some different experiments, and with that the J.J. Thomson found the electron. Okay, and what was the experiment? Is that is the cathode ray experiment, cathode rays experiment. Okay, by using a cathode ray discharge tube, they found the electrons. Okay, and have you know that where this cathode ray discharge tube is very popular is that the old TVs. What are the black and white old TVs were there, right? Okay, and those TVs were made up of this cathode ray discharge tubes. Okay, so how is that? Very simple. Whenever you pass the high voltage of current, and that current, what will happen? Passes through a cathode as well as anode with the empty tube, with some gas, what will happen when you passes the high voltage of current? The cathode releases some kind of charge, and that will charge pass from cathode to the anode, okay. And again in the anode, when you keep some fluorescent or phosphorescent material, do you know the fluorescent, phosphorescent? Fluorescent is means whenever you strike with some light, it glows, or okay, it glows, fluorescent, right? Fluorescent material, fluorescent tubes. Nowadays the tubes are coming, right? Okay, earlier tubes, in that there is some white powder, right? With the small light you can create more intense light by using that powder. That powder is nothing but fluorescent powder. That means when you pass some light, or when you through that powder glows with a more intensity, okay. So very similar here is also, whatever the charge here, it is come from the cathode and passes through towards the anode, and when it is falls on the backside of this fluorescent material, this fluorescent material glows, and that glowing you can see as a white spot. You can see some white spots. And if the other side, if something here it is falling here, then you can see here is a white spot, and remaining is in the dark, that means black. So like that, the TVs, black and white TVs, okay, whenever the on the picture, wherever the charge there you can see the glowing of light, that is nothing but a white, and remaining all the portion is nothing but a black, okay. Like that you can see the black and white TVs. Of course here it is not the our topic, the tubes, whatever the TVs are not our topic. Here the discovery of electron, that discovered by the J.J. Thomson, okay. And not only the electron, charge to mass ratio of electron also discovered by the J.J. Thomson, British physicist, okay, in the year of 1897, okay, right. And come to the charge of the electron. Next, charge of the electron. So here the charge by mass ratio invented by the J.J. Thomson, but here come to the charge, only the charge of the electron invented by the Millikan, okay. So what is the charge? What is the method he selected? Is that he selected a method, that is Millikan oil drop method. Millikan oil drop method. By using that, he found a charge of electron, that is 1.6022 into 10 to the power of minus 19 coulombs. Okay, right. So that was about the electron. Next, discovery of protons and neutrons. So the discovery of protons, that by using same cathode ray tube but with a small modification, right? Okay, so instead of the negative waves, they passed a positive charge, okay, by using the canal rays, okay. And here the protons they discovered in the 1886 by the Goldstein. And come to the neutrons, neutrons discovered by the Chadwick. The neutron discovered by Chadwick in the year of 1932, okay, right. Now we can see some important things about the electrons, protons and neutron, okay, in a simple table. So the electron, who invented? J.J. Thomson. And what is the symbol of electron? Is the E, small e. And what is the charge? Minus, okay. Generally the electron possesses the negative charge, that is minus 1.602 into 10 to the power of minus 19 coulombs. C is nothing but coulomb. And a relatively charge, okay. So that is a minus 1. And what is the mass of the electron? The mass of the electron is nothing but 9.109 into 10 to the power of minus 31 kgs. And the mass relatively, that in the that is 0.00054, and approximate mass is 0, because you see 0.00054, that means you will consider it as a 0. Okay, next come to the proton. Proton invented by the Goldstein, and a small p symbol. And what is the charge? Obviously it is opposite to the electron, same charge, it contains the same charge, but the symbol is positive. The symbol is positive. Okay, and relative charge, again it is a +1. And what is the mass of the proton? The mass of the proton is 1.672 into 10 to the power of minus 27. And when you come to the U, that is 1.00727. Okay, that means simply you can take it as a 1 approximately, right? And come to the neutron, invented by the Chadwick, and the symbol is N. And the charge, neutrons possess any charge? No charge. Neutrons are neutral, so they don't have any charge. And the relative charge is a 0. And whatever the mass, say almost similar to the proton, but there is a small difference in it. Okay, that is 1.6749. instead of 26, here is a 49 into 10 to the power of minus 27 kgs. And come to the use, 1.00867 use, and approximate mass, again it is 1. You see here 2 zeros are there, so you can take approximately as a 1. Okay, what is the U? The U is nothing but AMU, atomic mass unit. Atomic mass unit. Okay, right. And there is a small problem in the textbook, that is, how can you calculate the charge of 1 mole of electron? Calculate the charge of 1 mole of electron. Okay, so for that, what you should know, what is the 1 mole? What is the 1 mole? 1 mole is nothing but 6.023 into 10 to the power of 23, whatever it is, atoms or particles. Atoms are particles. Okay, and now you are talking about the electrons. 1 mole of electron, that means in a 1 mole of electrons, how many electrons will be there? 6.023 into 20 into 10 to the power of 23 electrons will be present, can be present in the 1 mole of electron. Okay, and you know that what is the charge of 1 electron? The 1 electron charge is nothing but 1.602 into 10 to the power of minus 19 coulombs. But what you should know is that what you have to calculate is that you have to calculate the 1 mole of electron charge. For 1 mole, how many? 6.023 into 10 to the power of 23 electrons. Okay, so that means for the 6.023 into 10 to the power of 23 electron charge is how much? Okay, for 1 electron this much. For these many electrons, how much the charge? Very simple, cross multiply, you can calculate the x, that is 9.6488 into 10 to the power of 4 coulombs, or else simply you can write it as a 96488 coulombs, or simply again they'll write like this, 96,500, 96500 coulombs. So this is the charge of 1 mole of electron. 1 mole of electron. Okay.